Somewhere in the cold black silence far beyond the planets, a machine built in the 1970s is still whispering back to Earth. Its memory is smaller than a modern car key. Its transmitter is weaker than a household light bulb. And yet, after more than 4 decades in space, Voyager 2 continues to send data from a region no human mission was ever truly expected to survive long enough to study. That fact alone would be remarkable. But what makes it more unsettling is not just that Voyager 2 is still functioning. It is what it has encountered along the way. Because when scientists expected a clear, clean boundary marking the edge of the solar system, Voyager 2 instead revealed something far more complicated, a frontier that refuses to behave like a frontier at all. Voyager 2 exists because of a rare alignment in celestial mechanics. In the late 1970s and early 1980s, Jupiter, Saturn, Uranus, and Neptune arranged themselves in a configuration that occurs only once every 176 years. This alignment created a gravitational pathway that allowed a spacecraft to hop from planet to planet, gaining speed with each encounter. What would normally have been a decades-long journey to the outer planets became a carefully engineered cascade of gravitational assists. NASA recognized the opportunity as irreplaceable. 2 spacecraft, Voyager 1 and Voyager 2, were launched in 1977 within days of each other. They were designed for a mission lasting roughly 4 years. Instead, they became the longest continuously operating interstellar probes in human history. By modern standards, Voyager 2 is almost absurdly primitive. It carries only 69 kilobytes of memory. Its data is stored on 8-track tape systems. Its transmitter outputs just 23 watts of power, less than many household bulbs. At billions of kilometers away, its signal arrives on Earth weaker than a faint whisper across a storm. And yet it kept going. Voyager 2 flew past Jupiter, then Saturn, then became the first and only spacecraft to visit Uranus in 1986 and Neptune in 1989. After that, it continued outward, leaving behind every planet it was ever designed to study. What remained was something far more ambitious than its original mission: direct exploration of the boundary between the solar system and interstellar space. That boundary is known as the heliosphere, a vast, invisible bubble created by the solar wind, a stream of charged particles flowing outward from the Sun. It acts like a protective magnetic shield, deflecting much of the high-energy radiation that fills the galaxy. Beyond this bubble lies interstellar space, where the Sun's influence weakens and the surrounding galaxy begins to dominate. The transition between these 2 regions was expected to be relatively clear. Scientists anticipated a distinct boundary called the heliopause, where solar particles give way to galactic plasma, and where the Sun's magnetic field should sharply change direction. But Voyager 2 did not find a clean edge. When Voyager 1 crossed this region in 2012, it detected some expected changes, including an increase in cosmic ray intensity and plasma density. But the magnetic field did not behave as predicted. The expected sharp directional shift was missing. That was already confusing. When Voyager 2 reached a similar region in 2018, the mystery deepened. It crossed the boundary at roughly 120 astronomical units from Earth and again recorded the expected changes in particle environment. Cosmic rays increased. Solar wind diminished. But once again, the magnetic field did not perform the clean flip theory had predicted. Instead of a sharp transition, there was a gradual, uneven blending of conditions. This forced scientists into an uncomfortable realization: the edge of the solar system may not be a fixed boundary at all. Rather than a clean separation between inside and outside, Voyager 2 suggested something more chaotic, a broad transition zone where solar and interstellar influences intermingle. A kind of cosmic interface rather than a wall. The implication is significant. If the heliopause is not a sharp boundary, then the heliosphere itself may not be a stable, symmetric structure. Instead, it may be distorted, dynamic, and constantly reshaped by external galactic pressure and internal solar activity. Models had predicted that the heliosphere should expand and contract in response to the Sun's 11-year activity cycle. Stronger solar wind should push the boundary outward. Weaker activity should allow it to contract inward. But Voyager 2 complicated that expectation. It crossed the boundary at nearly the same distance as Voyager 1, despite differing solar conditions during each encounter. That consistency suggested that something other than solar pressure alone is shaping the structure of this vast magnetic bubble. In other words, the heliosphere may not be a smooth balloon at all. It may be asymmetric, turbulent, and structurally irregular, shaped by unseen interactions with the interstellar medium. Instead of a clear edge, Voyager 2 appears to have entered a region of layered turbulence, where solar and galactic fields do not separate cleanly but instead entangle in complex ways. This is where the discovery becomes unsettling in a deeper sense. Because it means that the border of our solar system may not be a border in any traditional understanding. It may be a thick, shifting zone where two cosmic environments blend without a precise dividing line. Like trying to define the edge of a cloud while standing inside it. Voyager 2 made this discovery under conditions that should have ended its mission long ago. It is powered by radioactive decay, slowly generating heat that is converted into electricity. Each year, its power decreases. NASA has been forced to shut down instruments, heaters, and systems one by one just to keep it operational. Temperatures far below its original design limits have become routine. Yet the spacecraft continues to function, transmitting data across billions of kilometers with remarkable stability for its age. It is, in many ways, a machine operating far beyond its expected lifespan, continuing to reveal information about a region no one had ever directly sampled before. And perhaps that is the most important point. Voyager 2 was never meant to explore interstellar space. It was built to study planets. Yet it ended up crossing into a domain that redefined how we understand the structure surrounding our solar system. The longer it travels, the more it reveals that our conceptual map of space is incomplete. The heliosphere is not a simple protective shell. It is a dynamic structure shaped by forces that are still not fully understood. The transition into interstellar space is not a step. It is a process. And that process does not behave the way textbooks once suggested. Beyond the science, there is something almost symbolic about Voyager 2's continued journey. It is a relic of an earlier technological era still operating at the edge of human reach. It carries the golden record, a message from Earth intended for a universe that may never respond. Long after its instruments fail, it will continue drifting outward into interstellar space for millions of years, silently moving through regions no human will ever visit. In that sense, Voyager 2 is more than a spacecraft. It is a reminder that exploration does not end when missions conclude. It ends only when there is nothing left to discover, and Voyager 2 has already shown that we are far from that point. Because even at the edge of the Sun's influence, the universe refuses to become simple. And the most important discovery Voyager 2 has made is not a single measurement or reading, but a realization. The boundary of our solar system is not a line we cross. It is a region we enter without ever fully understanding its shape. And that region is still teaching us how little we actually know.